In this next example, we're being asked to find the area of the region enclosed by the line y equals x minus 1, which is going to be pretty straightforward to graph, and the parabola y squared equals 2x plus 6. Now, usually with a parabola, we're pretty accustomed to x being the thing that's squared and y is not squared. Now it's the reverse. What that should remind you of is this phenomenon of sideways parabolas. Here's a quick way to deal with graphing this that will be a helpful way to actually look at the problem. We can actually think of x as a function of y instead of y as a function of x like we usually do. And so if we do that, we're going to treat x like it's the dependent variable, y as the independent variable, which means we should solve for x in this equation. And if we do that, we're going to get that x, which is our f of y, is y squared minus 6 over 2. So how do we graph that parabola? Well, it'll help to figure out the vertex and the y-intercepts. Instead of x-intercepts like we usually might, we want to figure out y-intercepts. Let's start by figuring out y-intercepts. The y-intercept is when x equals 0, and we need to figure out what y will equal. So I will just solve this equation. And I will get that y is equal to plus or minus square root of 6. So when x equals 0, y equals plus or minus square root of 6. Square root of 6, let's see, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So that means square root of 6 is somewhere between 2 and 3, probably a little closer to 2. So I can graph these points here. And we should remember that the axis of symmetry of any parabola is always going to be, assuming we have two intercepts, in this case two y-intercepts, the axis of symmetry of the parabola will always be exactly halfway between these two. So the axis of symmetry is actually the x-axis, which means if we plug in y equals 0, we will get the vertex. So what is x when we evaluate this function in terms of y at y equals 0? We get 0 squared minus 6 over 2, which is negative 3. So that means when y equals 0, we have x equals negative 3. If we put that all together, we'll get a parabola that looks something like this. And next we just have to graph the line and then figure out how to set up our integral. So the line y equals x minus 1 is the standard y equals x line, but it's shifted down 1. Let's see what that looks like. That'll be something like this. Okay. So what we see is that there's two places where the line and the parabola meet. And, as much practice as I have graphing by hand, I can't trust that I know exactly where these points are just by looking at the graph. And that's why I have to do some algebra. So the question is, where do these two equations meet? Well, this equation says that y equals x minus 1. This equation says y squared equals 2x plus 6. What I could do is I could plug in x minus 1 for y into this equation and see how that goes. So what we're doing now is We're finding the points of intersection. It's important to know why we're doing the algebra we're about to do. We're trying to figure out where these points are exactly, because that'll help us know how to set up our integral. Okay. Well, what do we have now? We have x minus 1 quantity squared, which is x squared minus 2x plus 1, and that equals 2x plus 6. If I gather everything together on one side, I have x squared minus 4x minus 5 equals 0, which I believe you can factor. I think if we do x minus 5 times x plus 1, we will get the solutions x equals 5, x equals negative 1. And that looks, well, I mean, my graph over here, I didn't do a great job, but this part over here on the left looks pretty good. There's a little bit of a problem though. My integrals are always in terms of x. They're always written in terms of x. They're always with respect to x. I'm always thinking, where do I go from left to right to start and finish? Now what's weird here is I could set up an integral from left to right, and in that case I would have to figure out an expression for the top curve and an expression for the bottom curve. They both happen to be the same curve, but when they're determined in terms of y. So, okay, that's a little confusing, first of all. And then if I ignore that and just go, continue from there, going to the right of negative 1, I have top function is this, bottom function is this. But I keep saying the word function, and we defined our function in terms of y. So we're going to come back to this example because we could do this now, but I don't want to do this in a way that will be more difficult than it needs to be. So all the work we've done up to now is actually perfectly useful and good. We just want to develop a better technique for doing a problem like this, and we'll come back to this one.